Hey everyone, in today's we are going to see about embeddings and why we need embeddings and how to use embeddings. So in general, how we see an object or a living being or anything it may be, we see something like cat and we visualize the image of a cat like it will have a fur, a tail, and it catches rat. Every pictorial images that we just imagine about it because we have seen and learned from it. So that is how human understands. But how machine understands? So we all know machine can read through numbers. It is all about numbers for machines. So we teach about cat through numbers, but how? So when we use embeddings, it converts a word into numbers, numerical format. From that, it understands what is what. Numbers, in the sense, not just numbers, it is a group of numbers in a matrix format with certain dimensions, it will be. So, we're going to see that step by step, how it is and why it is. For example, we see here king, which will relate to man, and women relate to queen. So, how these combinations can happen? It happens through embeddings, and how we can teach the machine all these through embeddings, of course. So, how we take a raw sentence and we split the entire sentence, which means tokens, and the every sentence that you split and word by word thing is tokens. So after tokenizing, we just see the entire numerical format of it. So we need for every word in it. So each token we take like the cat sat on a mat. So cat is a living being. We can't just put a table on it like the table sat on the mat. We can't say that because it is not something that can be. It can be placed on a mat, but it can sat on a mat. So sat is a verb. So how we teach a machine all these with a meaning. So for that we have this numerical vector format which will have like 300 dimensions. So these dimension depends on the corpus that we use. The data set size we use. So it may be like even 1500 or anything it may be. It depends on the vocabulary size that we use or we need. So cat has these number of dimensions, and these are the numbers which represent cat. Just imagine a table where we have rows and column and we just place where these belong to, which is nothing but animal group. So we'll see step by step. Let's say let's take king, which in the 16 dimensions, we have like these number of vectors for it. And it is highly influential towards a man, king, or anything. It may be like boy, group of gender. For cat, we have these, and for dog, we have these many. But how we'll see. So these are types of embeddings we can use. So word to vector, glove, fast text, multimodal, sentence embeddings, BERT or transformers also we can use. It directly says. Why transformers? Because it understands river bank, which is not equal to bank account. So that much intelligent it will be, more than a neural network trained model. So let's compare with a few of the terms. So when we take word to vector, we have like vector size of 100 to 300. But when we go with sentence embeddings, we can rely up to 1536. 1536. So this big and much useful when we use models like RAG. Let's try for quite a bit of understanding. So we have like points plotted based on the tokens and the split happened. So we have lion, cat, kitten, which comes under animal group. And here we have other transport objects. And similar to that, we are just grouped based on the values that I have assigned, as in dimensions. But how to teach the machine that it is related or relevant to each other. So let's take like cat and dog, which are animal group, which is similar. So the score is 0.87. Let's take the car in here. So you can see the score difference 0.15, which is like vast, and the difference is like more. And let's say pizza, it's even more less. Let's take mountain again. So it depends on what we are actually having. And when we take oceans and mountain, both are different because it is a mountain and it is an ocean. So let's say like apple and pizza. Both are food and we have like 0.72 percentage of score. So this is how the combinations, I mean word to vector match happens, and we can see the relevancy of it. So when to use any data type which is text, audio and image, you can use embeddings. You have to use embeddings. We can use it for semantic search, recommendations, chatbot, RAG, text classification or clustering model, finding duplicates, and understanding languages. We can use embeddings. We have to use embeddings because we cannot teach the machine numbers otherwise. These are the general steps that we need to take. You need to know like why we are doing, and depends on the corpus, choose a embedding model. So prepare your data for it and store an vector DB, which is nothing but your dimensions of word to numbers, and use any pre-trained model like semantic search if you are using. You can have this sentence embedding, which is a general one. Everybody uses it. All mini LM L6 version 2. It is free, fast, and great quality it has, and generate embeddings. So that is how embeddings, in the sense like we understand what this particular word is about. So hello world means greetings, it should say. So that is what this particular sentence embeddings will do. And conversion from word to numeric, which will be your vector DB. And that's all. You will have your task that you need to proceed with from step 4. So this is how this entire embeddings work, and you can ask me if you have any doubt on this. So that's all I have for today. Thanks for watching. Bye.